So the last of our topics for today is this one, and this is a topic that tends to be more complicated, but it ends up, if you understand the idea behind it, it ends up being even easier. So let's take a look here. The difference with this one is that these are multivariate polynomials now. So we don't just have x, we don't just have y like we did in that last lesson in the 9th, or in topic number 9. What we have here is 5x squared minus, or sorry, 5x squared times y minus 2x plus this. So when we are adding polynomials together, we do not have to do anything. We're going to distribute a plus 1 to the second set of parentheses. But when we do that, it doesn't change anything. We still have the same exact polynomial in the parentheses, even after I distribute that positive 1. So taking a look here now, you have to remember that we're only going to combine like terms. This looks like a huge mess, but it's actually a lot easier than it looks. So what I want to do first is I want to look at the first type of term that I have. And that is right here, it's my 5x squared y. And what I have to look for is the combination of x squared and y in another term. So what you're going to notice is that this term right here also has an x squared and a y attached to it. So because those two terms have the same variables and the same exponents, I can combine those together. So when I have 5 of these and 7 of these and I add them together, that just means that I have 12 x squared y. Okay, now take a look at the negative 2x here. The next term is negative 2x. This has an x in it, but this has an exponent of 2. So these two terms right here are not like terms. But this one and this one are like terms with each other. So negative 2x minus 3x, that's negative 5x. And then the last one, this one right here, negative 4x squared. You notice that there's nothing that I can combine that with. So I just put this at the very end. Now here's the thing. This looks nasty. It looks like a really ugly answer. And I'm sure there are going to be some of you out there that want to combine this more. There's going to be some people that don't like this as their final answer and they want to do more with it. The thing is, there are no like terms here. I've got this term here, this term here, and this term here, and they are all different. The one on the left and the one on the right both have x squared, but this one on the right doesn't have a y. These two, the one in the middle and the one on the right, both have x's, but this doesn't have the exponent of 2. So none of these three terms are like terms. I got 2 more here for you. I don't know how this one got on there. Sorry about that. There we go. That second one wasn't even the same topic. So let's take a look at this now. We're adding again. And when we're adding, we don't need the parentheses. So I am going to rewrite this just because it's good to see it written out a different way. I'm going to try to give it a little bit more space so you can see a little bit better where the terms are. So when I take this plus 1 out in front and I distribute it, remember nothing changes. I have the same 3 terms on the inside that I have that I had before I distributed. So this is what I have. And then once you have it written out like this, like I said, my goal in writing this out for you was to make it a little bit easier to read, a little bit easier just to distinguish each term from each other. And now you can start combining stuff. So you've got this one here. It's got x to the second, y to the third. If you look at this one, it's got x and y. It's got 2 and 3, but they're flipped. This is x to the second. This one's x to the third. So these two are not like terms. This term doesn't have an x. This term is the same as this one here. We'll get back to this one in a second. But this has x to the third and y to the second. So those two end up being like terms, but neither of them are like terms with this first one. And then if we go here, we see this fifth term here has the same combination of variables and exponents. So I've got 4x squared y to the third, and I subtract 6x squared y to the third. So if I've got 4 of something and I subtract 2, that leaves me with -2. And when I do that, I don't change the exponents at all. Okay? If you had 4 box minus 6 box, it doesn't matter what's inside the box. When you subtract them, you're going to have -2 box. This can be anything here. It could be x, it could be apples, it could be, in this case, x squared y to the third. It could be anything. But when I have like terms, I don't change the exponents. I only do that when I multiply. The next set of terms that I have here are 2x to the third y squared. And you'll see here, as I mentioned just a minute ago, this term right here has the same thing. Same exponents attached to the same variables. So notice I got 2 of these here, and I've got 3 of them there. When I subtract, I'm going to have just 1 of them. I'm actually going to have -1 of them. 2 minus 3. So there's that second term. The last thing you should notice here then is that our last 2 terms that I have here are both the same. They both have y squared and no x's. So because of that, I can combine those together. And when you do that, you get -7 plus 5, which is -2. And I keep the exponent and the variable the exact same. So this is your final answer. And the last thing I want to just bring up, like I mentioned before, you don't have any terms here that are like terms. This first term has x squared y to the third. This one's got a 3 and a 2. It's got an x and a y, but the letters are flipped. Instead of x2y3, it's x3y2. And this last one here, -2y squared, that doesn't have an x, so you can't combine that with anything. So this would be your final answer.